I'm Jonas and I'm one of the co-founders of V3Lab. I did a PhD at the Vienna Center for Quantum Science and Technology together with my co-founder Chiara, where we finished our work in 2018. We used a technology which allows us to control light on the nanoscale in thin pieces of glass and used that for quantum computation experiments. Then we had the idea to spin this off in a company for display applications and founded V3Lab. We're operational since 2019 and have now also our own facilities, our own clean room laboratory at the Tech Park in Vienna with a team of 9 people. We've been able to raise a total funding of 2.8 million euros, around half from the public sector and half from venture capitalists. The key technology which we are using is called direct laser writing. And what it does, it takes a pulse laser beam, focuses it into a piece of standard glass, and then by translating the piece of glass, we can create modifications in this glass. So we locally melt it. And by creating many of these modifications, we're able to control the flow of light within the glass. On the right side, you can see how such a network of light channels that control the light flow in a glass look and distribute the light from single light source at the left side to many thousands of pixels on the right side. It's important to notice that we don't have to have such a complex and wide network to distribute the light. This can also be compactified in later display products. We use this technology to create something which we call the laser lit chip. And the unique capability of this technology is to create a tightly spaced grid of laser beams coming out of a thin piece of normal glass. And what you can see here, that on the left, we couple in laser light with single laser dyes, one per color typically, and then we create a huge array of beams coming out of the glass. Why is this technology important? The main benefit of this technology when used in normal displays is that it can drastically reduce energy consumption. Somewhere between 40 and 80% is possible. This of course has very strong implications on the battery life, in particular if used in smartphones or tablets. At the same time, because I'm having a low energy consumption, I can also increase the brightness of the display and increase, for example, sunlight readability. As you well know, the mobile market is very big. Obviously, with a new display component, we would only target the premium market segment of that. But even there, almost 400 million units are sold per year. And if we manage to bring this technology to all these units, we can make a very high profit just from the license income. Particularly appealing for us is the 3D display market. Because basically what we offer is magnitudes of better light control within a display. And for 3D displays, this really matters. Because you need to create different viewing angles, different views for people looking on an object from different perspectives. And here we recently filed a patent how to leverage our technological capabilities to create a 3D display with 10 times higher resolution than what competitors can do. The 3D display market is still in its infancy, but it's growing fast, and it should reach around 260 billion euros in 2028. Our business model is focused on the production and licensing of intellectual property. This means that we don't want to mass manufacture display components ourselves. We want to develop the base technology and then help partners, most likely in Asia, to mass produce these components and bring them to the markets. This means that we are very focused on patent development, and we have filed 6 patents so far, both on the general application layer as well as on the technological problems we encountered and we think are key to make an actual product work. We've been able to push the technology ahead at a fast pace. We're operational since January 2019, and first we were focused on establishing a basic concept of increasing the pixel number and density within the module. Then later on, we were focused on increasing uniformity and matching the laser beam array through LCD grids, as this is the main request by partners posed to us. We have very good industry connections and are talking to almost every major display manufacturer. They all see our technology as extremely interesting and potentially disruptive. We also synchronize our development with their requests and focus on what they see as the first things to be shown in prototypes to enable then business partnerships built on that later on. We've been very lucky by having a very valuable advisor in Mark Verral. He's the former director of display research at Merck, a major industry player. And he's advising us both on the technological as on the market side of the display market. We've been featured on the Forbes list of spin-offs to watch in 2021. And we've been featured also on the main news blog of the display industry in 2020. For next year, we've been invited as a keynote speaker by Sony to the Laser Display and Illumination Week. In 2022, we are raising 3 million euros to facilitate further technology development. This is both going to more advanced equipment to create prototypes with higher specifications, as well as expanding the team. On the business development, the next 2 years will be targeting generating first revenues from industry partners, making collaborative projects to showcase our technology in a way that is fitting a particular product idea by them. Thanks for listening. If you want to learn more, just get in touch either with me here at the conference or drop us an email, and we can set up a meeting and discuss further.